Today, I want to explore a profound question. Are the laws we use to describe the universe truly universal? Or are they just human-made tools that approximate the dynamic and unpredictable nature of reality? We've always relied on mathematical models to describe the world around us, and for good reason. These models, especially the simple ones, are powerful tools for prediction and understanding. However, we need to ask ourselves, do these models truly reflect the laws of nature? Or do they simply help us make sense of the complexities we observe? In my view, the laws we speak of, whether in physics, chemistry, or any other field, are not inherent truths of the universe. They are human-made descriptions, approximations based on patterns we observe. The universe, after all, does not inherently speak the language of mathematics. While we solve differential equations and apply Euclidean geometry to understand physical systems, nature itself does not solve these equations. Nature does not follow rigid formulas. Instead, it follows dynamic processes that are, at times, chaotic, unpredictable, and far more complex than our models can fully capture. Take, for example, the concept of non-linear systems. These systems, which describe most phenomena in nature, are inherently difficult to predict. The weather, for instance, can only be forecasted with limited accuracy. This is because non-linear systems are sensitive to initial conditions and small changes, which can lead to vastly different outcomes. The unpredictability of such systems challenges the traditional view that the universe is governed by immutable, fixed laws. Another example comes from geometry. The buildings we construct are based on Euclidean geometry, with shapes like squares, rectangles, and cones. Yet, when we look at nature, these perfect geometric forms rarely exist. Instead, nature's geometry is fractal in nature, self-similar, dynamic, and constantly evolving. From the branching of trees to the formation of coastlines, nature follows a pattern of growth that defies rigid Euclidean structures. This shows us that the way we model nature with fixed geometric shapes is vastly different from the fluid, fractal reality we encounter in the natural world. What this all points to is a critical shift in how we think about the universe. Perhaps the laws we've constructed are not permanent, unchanging truths, but models that help us predict and understand nature within certain constraints. These laws are useful approximations that work well in certain contexts, but they may not capture the deeper, more complex truths of how nature truly functions. In the end, our models, whether simple or complex, are just that, models. They are tools to help us understand the world, but they are not the ultimate explanation for how the universe operates. As we continue to push the boundaries of our knowledge, we must remain humble in recognizing the limitations of our models and be open to new ways of thinking that might better reflect the dynamic, ever-changing nature of the universe. The journey of discovery is never-ending, and with each step we come closer to understanding the profound mysteries of existence. Stay curious, keep questioning, and embrace the unknown. If you're interested in these topics, be sure to follow Professor Mohammed Qasim Mahjani's YouTube channel for more insights and explorations.